We are continuing in the chapter for trigonometric identities. We are now in section 4.4 of our workbook, where we will look at product to sum and sum to product identities in our formula packet. That would be towards the bottom of, well, I guess the middle of page 3, product to sum and sum to product identities. What do these identities do? They take a product of trigonometric functions and convert it to a sum, or they take the sum of trigonometric functions and convert it to a product. In calculus, we like to have sum of trigonometric functions because it's easier to do calculus with this. In fractions, we want to factor fractions to simplify, so we like to convert sums in the numerator and the denominator to products so that we can simplify. So the two kind of formulas have their own application, and you can see it in various different types of problems. How do we derive those? If we have the formula for the sum of for the cosine of the sum of two angles, if you remember, the formula is cosine of A times the cosine of B minus the sine of A times the sine of B, and the difference, cosine of A minus B, was the cosine of A times the cosine of B plus the sine of A times the sine of B. If I add those, the second terms with the sine will add to 0, and I will end up with the cosine of A plus B plus the cosine of A minus B equals 2 times the cosine of A times the cosine of B. And that will give rise to the first formula that the product of two cosines of different angles equals 1/2 the sum of the cosine of the sum angle plus the cosine of the difference angle. Now, if I did not add those two, but I subtracted, so if I subtracted B minus A, let me put the negative A here, A being the top one, then the cosines will cancel and I will have sine A plus times sine B minus negative sine A sine B. So I would have the cosine of the difference minus the cosine of the sum equal to 2 times the product of the sines of the two angles. And that will give rise to the first identity on the left in the second row, and where it says that the product of the sines of two different angles equals half the difference of the cosine of the difference minus the cosine of the sum. If I use the sum, the sine of the sum and the sine of the difference identities, and I add them and I subtract them, I will get the other two identities, and I leave that for you to try to verify and prove if you want. You can also read the book or watch more videos if you are not sure how to do it by now. But I can use this to write each product as a sum. So I'm going to go in my formula packet. I'm looking for a sine of A, with A being negative 4x, and times the sine of B, with B being 8x. And this is the product of two sines, and the product of two sines is half the difference of cosines. So that will equal 1/2 of the cosine of A minus B, negative 4x minus 8x, minus the cosine of the sum, negative 4x plus 8x. This is 1/2 the cosine of negative 12x minus the cosine of 4x. And if I use even odd identities, I can convert the negative 12x to a positive. I mean, I don't know if x is positive or negative, but just a positive algebraic expression. The cosine of negative 12x must equal to the cosine of x because the cosine function is even. So that will be 1/2 cosine of 12x minus the cosine of 4x. Now pay attention to this 1/2. 1/2 goes to both of those trigonometric functions. So if you want to distribute, it has to be 1/2 cosine of 12x minus 1/2 cosine of 4x. The next one is 2 times the cosine times the cosine. Let's call, so this is cosine of A times the cosine of B. And there is a 2 here, so actually they never divided by 2, or the product of the cosines will be 1/2 of a sum or a difference, and the 2 and the 1/2 will simplify. Now cosine times cosine is 1/2 the cosine of the sum of the cosines of the sum and the difference of the angles. So that will be, let's shrink this to make us some room here. There. So that will be 2 times 1/2. And in here I will have the cosine of the sum, 7x halves plus 3x halves, plus the cosine of the difference, 7x halves minus 3x halves. And the 2 and the 1/2 will go away. So I will have the cosine of 10x halves is 5x plus the cosine of 4x halves, that will be 2x. The last one is a sine times a cosine. So this is sine of A times the cosine of B. A is the angle 7 pi eighths. B is the angle pi eighths. It's a sine times a cosine. And a sine times cosine is half of the sum of the sines. So this will equal to 1/2 sine of A plus B, 7 pi eighths plus pi eighths, plus the sine of the difference, 7 pi eighths minus pi eighths. This is 1/2. 7 pi eighths plus pi eighths is 8 pi eighths, so that's the sine of pi, plus the sine of 7 pi eighths minus pi eighths is 6 pi eighths, which is 3 pi quarters. If we go on our trigonometric circle, pi is right here. The sine of pi is equal to 0. 3 pi quarters is here. The sine is equal to square root of 2 over 2. So 1/2 of square root of 2 over 2 will be square root of 2 over 4. That will be the value. Write as a sum or a difference. This is the product of sines. The products of sines is 1/2 the difference of the cosine A minus B and minus the cosine of A plus B. If A is 4x and B is 9x, I will have 12 times 1/2 cosine of the difference, 4x minus 9x, minus the cosine of the sum, 4x plus 9x. 12 times 1/2 will equal to 6. Cosine of negative 5x minus the cosine of 13x. And the cosine of negative 5x equals the cosine of 5x, because the cosine is an even function. And if I were to distribute the 6, I will get 6 cosine of 5x minus 6 cosine of 13x. Cosine times cosine is the sum of cosines. So I have here 18 times 1/2 cosine of a plus b, 29x plus 17x, plus the cosine of a minus b, 29x minus 17x. 18 times 1/2 is 9. And if I distribute 9 times the cosine of 46x plus 9 times the cosine of 12x.